All right, so we're looking at key features of a function. And the first question we have is, how do you tell if it's a function or not? So when we look at a function, we can either look at it as a table, as a graph, or as a set of ordered pairs. But the key takeaway is each x value has only one y value, okay? So if we look at this table, my x values aren't repeating, which means for sure this is a function. However, if we look on the other one, my input has 4, but they have different outputs. So each input, so the input of 4 does not have one output, but it has 2 outputs. So this is not a function. Okay. All right. Now, in a graph, we have a special way of telling, and that's to use the vertical line test. So what a vertical line does is create, for as we move it, the input of 1 has an output of 3. The input of 2 has an output of 4. Each input only has one output, so yes, this one is a function. So we come across here, it only ever touches the line at one point, so yes, that is a function. Down here, yes, 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 yes. Oh, right here, it does not. The input of 4 has 1, 2 outputs, so this would not be a function. And then, checking this one, every single point touches twice, so this is definitely not a function. And just to show it's not at any point, I'm just going to make a couple x's. This is not a function as well. And these ones, yes, those are functions. So after we decide if it is or is not a function, we also want to find the domain. And domain is going to be all of your x values. So we start with the leftmost or smallest x value, and we go to the rightmost or largest value. Now, we do need to know what we're going to use for brackets. So if we have a parenthesis, that's when we have an open dot on a graph. What that means, it's not actually part of your domain. When it's filled in or a closed dot, that means it is part of your domain. And in those situations, you want to use a bracket. So you don't use both, it's one or the other. And the same thing would be true for the range. But range deals with y values or the height of your points. So the lowest value on your y-axis and the highest value on your y-axis. And it follows the same rules for a closed dot as it would for an open dot. Okay. The y-intercept is where a line crosses the y-axis. So for the y-intercept is where it crosses the y-axis. So this is your y-axis, meaning this is your y-intercept. Okay. It's also where x equals 0. So x is 0 in our table, which means this is our y-intercept. Okay. So that's how you can find the y-intercept. The x-intercept is where it crosses the x-axis. So the x-intercept was the point where it crosses the x-axis. So this is my x-axis, and it crosses right here at -2. This is my x-intercept. And it's also where y equals 0. So where y is 0, what is x? So it shows up in our table if we have those points. Okay? So the maximum and the minimum refer to your y. It's based on the highest and lowest points. So you're looking for the highest and the lowest. And you can use your range to find that, or use the maximum and the minimum to help you find your range. So we have our highest point and our lowest point. Increasing and decreasing, and as well as constant. Increasing means where is the graph going up? Decreasing is where is it going down? And remember, we read graphs just like we read books, left to right. So left to right. Okay. And then we also have constant, which isn't on here, but constant is where it's not going up or down. It's just flat. And we talk about it in terms of our x values. So x values, so it's just like the domain, but it's just the sections or intervals where it increases or decreases. So only where it's increasing, or only where it's decreasing, or only where it's a constant. All right. So we have some practice down here. And for the practice, I'm going to put little arrows on here because I like to either have a dot on my graph that's nice and clear, or arrows. And because it's not very clear, I'm going to put arrows. Okay. So for domain, this arrow is pointing in a down direction and in a left direction. This one's pointing in an up direction and a right direction. That's how I see it. Okay. So what that means, arrows means it kind of goes on forever. And we have a special sign, and that's infinity. So for domain, it is going to be going in its left to right. And because we have arrows going that direction, I'm going to say it's from negative, my smallest, infinity, goes on forever, to positive infinity. And we never actually get to infinity, so I'm using parentheses. Okay. So the range is going to be going up and down forever. So the range would be from negative infinity, my smallest, to positive infinity, my largest. Decreasing. So now it's kind of where we want to break it up into sections. So I'm going to put some bars on my... So at this point here is where it's changing direction. I'm going to move that over until it's at the top. So for me, I think it's changing direction right there. And it changes direction right here. Okay, so when I talk about decreasing, it decreases from here to here. So decreasing, and we talk about this in terms of our domain or x values, it's decreasing from -1 until 2. So my smallest is -1 and my largest is +2. So this section right here. Now, because it's going up and then down, it's doing two things at the same time, that can't happen, so I'm going to put a parenthesis. And because it's going down, decreasing, but then increasing at -2, I'm going to go ahead and put a parenthesis for both. And that's the only area where it's decreasing, because remember, we read a graph from left to right. All right, increasing, it's increasing from here to here and from here to here. So from the left, because we have this arrow going to the left, it's going to be from -infinity, -infinity, which you never reach, until -1, where it changes direction. So the section I'm talking about in domain is right here. So from -infinity all the way until right here, -1. But it's also, we're going to put a union sign, which is a capital U, also increasing from -2 until +infinity. And because this is a place where it changes direction, that's going to be a parenthesis. And we never actually get to infinity, so that's going to be in a parenthesis. So, okay. Now we're going to look at, I probably should use different colors for that. Now we're going to look at x-intercepts. Where does it cross your x-axis? So I'm going to get rid of some of this so it's not so busy. But x-intercept, it touches here and here. So at -2, 0, as well as 3, 0. And notice how when our x-intercepts, y equals 0. Our y-intercepts, where is it across our y-axis? Right at 0. So 0, 0. And for our y-intercepts, notice how our x is 0. So our maximum and our minimum. So our maximum, because we're looking at going up forever, our maximum we're going to go ahead and call infinity. And our minimum, which goes down forever, we're going to call -infinity.